I want to start today by putting a very specific image in your head. Imagine you are sitting in seat 14A, looking out the window at the wing of an airliner cruising at, say, 35,000 feet. You're trusting your life to physics? Sure. But you are also trusting your life to millions of lines of code.
And that code, it operates under a designation that keeps engineers up at night. It's called criticality level A.
Criticality level A. It sounds so, I don't know, bureaucratic, but according to the source material we're diving into today, the definition is, well, it's terrifyingly simple. Failures here are defined as catastrophic.
They don't mince words in this industry. Catastrophic means a hull loss. It means a crash. It means multiple fatalities or, massive environmental damage. It is the absolute no-fail zone.
So here is the tension we're exploring today. On one hand, you have the aerospace industry. It's built on caution. It uses a standard called DO178C, which is rigorous, slow, and completely obsessed with paperwork.
Right. The motto there is basically document everything, then check it 3 times, then have someone else check your checking.
And on the other hand, you have the modern software world, the world most of us live in, the world of Agile, Scrum, startups. Their motto is usually move fast and break things.
And immediately you see the problem, right?
Yeah.
You really, really do not want to move fast and break things when you're building the autopilot for a 747.
Exactly. So the mission for today's deep dive is to unpack this fascinating research paper. It's titled Scrum4DO178C, and it asks a seemingly impossible question. Can you actually use a move-fast methodology like Scrum in an environment where failure is literally not an option?
And just to set the stakes, this isn't a theoretical paper written by professors in a lab. This is a case study from a real industry project working at that highest criticality, level A. They actually tried to merge these two opposing worlds.
Okay, let's unpack this. Before we get to the solution, which is surprisingly clever, we need to understand why these worlds, why they hate each other. I think most listeners know what Agile feels like. You sprint for 2 weeks, you release, maybe fix bugs later. But what is the deal with this aerospace standard, DO178C? Why is it such a roadblock?
So, DO178C is the Bible for certification bodies like the FAA in the US or EASA in Europe. If that code on the plane hasn't passed this standard, the plane doesn't fly, period.
Does it tell you how to code? Like, does it say, thou must use C++ Auth or something?
No, and that's a common misconception. It doesn't care about the language or the development model, not explicitly. It cares about one thing: evidence.
Evidence.
Traceability. You have to prove that every single line of code exists for a reason. You trace a line of code back to a low-level design. You trace that design back to a high-level requirement. You trace that requirement all the way back to a system safety goal. And then you have to prove every single link in that chain was reviewed and tested.
That sounds exhausting, and honestly, it sounds like it would take forever.
It is substantial. In the industry, they typically visualize this using something called the V model. Picture a giant letter V.
Okay, I'm picturing it.
You start at the top left, you slide down the left side, defining requirements, then design, then, coding at the very bottom point of the V. Then you climb up the right side, testing the code, testing the integration, testing the full system. It is extremely sequential. You don't start the right side until you've completely finished the left side.
So it's the classic waterfall method. You do all the thinking up front and all the checking at the end.
Precisely. And that creates a massive certification wall at the end of the project. You might have great code, but if you haven't produced the mountain of paperwork to prove the traceability, you have nothing.
And this is why Agile struggles here, because Agile is all about working software over comprehensive documentation. I mean, be honest, if I'm a developer in a typical Agile team, my goal is just to get the feature working, right?
Right. In a typical tech startup, the definition of done is something like, does the feature work? Great, ship it. It works on my machine. Exactly. But in aerospace, done means the requirement was written, the design was reviewed, the code was written, the code was reviewed, the test was written, the test was executed, and the results were analyzed. If you miss one of those steps, the software is not done.
So if I'm a naive Agile coach and I walk into Boeing and say, let's just do Scrum, we'll figure out the docs later, I'm basically telling them to fail their audit.
You're telling them to build a product they cannot legally sell. You'd end up with perfectly working software that is grounded indefinitely.
Okay, so that's the trap. It seems like you have to choose. Move fast and fail the audit, or move slow and pass. But this paper, Scrum4DO178C, claims there's a third way. So how do they actually solve this? Did they just water down the rules?
Not at all. They didn't throw out the rule book, and they didn't just stick to the old ways. They reinvented the rules to fit the sprint. The first big change was about leadership. In standard Scrum, you have a product owner, right? The PO. One person who decides what gets built.
The voice of the customer.
That works fine for a shopping app, but for an airplane, I mean, one person simply cannot know everything. The requirements are just too dense. You have safety constraints, aerodynamic limits, hardware interfaces.
So if you rely on one PO, they're going to write a user story like, as a pilot, I want to turn left, and miss the fact that turning left too fast rips the wings off.
Exactly. So the first adaptation in Scrum4DO178C is the multidisciplinary PO team. Instead of one person, it is a squad. You have safety engineers sitting right next to domain experts and software architects.
Hold on, though. Doesn't that slow things down? Designing by committee sounds like the opposite of Agile.
Well, in the preparation phase, yes, it takes more effort. But remember the context. No fail zone. This team defines the high-level technical specs in incredible detail before the developers even touch a keyboard.
So they're front-loading the complexity.
Correct. They ensure the what is incredibly precise so the developers can just focus on the how of the code without accidentally violating safety rules.
Okay, I can see why that's necessary. But here's the part I'm skeptical about. You have a bunch of developers. They want to code. How do you stop them from just coding and ignoring the paperwork? That seems to be the biggest hurdle in any engineering team.
This is the second, and I think the most important, adaptation. Predefined tasks within the backlog.
Break that down. What does that look like in practice?
In normal Scrum, you give the team a ticket, say, implement altitude display. The team decides, okay, we need to write a database query, maybe build a UI component. They make up the tasks.
Autonomy.
In Scrum4DO178C, the tasks are mandatory. They are hard-coded into the process. The source lists them out explicitly. For every single feature, you must have a task for. Define low-level requirements. Review low-level requirements. Implement source code. Review source code. Develop test cases. Execute tests.
Wait, so I can't just create a task called write the code?
No, the system won't let you. The ticket comes preloaded with those subtasks.
And I assume I can't move the ticket to done until I've ticked all those boxes.
Exactly. And this is the genius of it. It forces the traceability into the daily workflow. You cannot say, oh, I'll do the documentation next month. The system physically stops you from finishing the job until the documentation for that specific piece of code is done.
I see. So it breaks that massive certification wall into thousands of little bricks.
Yes. Instead of a mountain of paperwork at the end of the year, you have a tiny molehill of paperwork every afternoon.
That sounds better psychologically, honestly.
Yeah.
But I'm looking at the V model again in my head. Remember, the V model says you design on the left and test on the right. Usually those things happen months apart. How does this system handle testing?
This brings us to the third major adaptation, integrated V&V, verification and validation.
Moving testing into the sprint.
Yes, but there's a logistical nightmare here, right? Let's say you write some code on Tuesday. You want to test it on Wednesday, but maybe that code relies on a piece of hardware that isn't ready yet, or it needs to talk to another system that hasn't been built.
Right. You can't system test a fragment. If the landing gear hardware isn't there, I can't test the landing gear software fully.
So the researchers used a concept called parallel streams. The source distinguishes between Scrum Type A and Scrum Type C.
Okay, hold on. Type A and Type C, unpack that for us without getting too bogged down in diagrams.
Think of Scrum Type A as sequential. You do a sprint, you stop. You plan the next one, it's stop and go. Scrum Type C is all at once. It involves overlapping phases. Scrum4DO178C combines these into a pipeline.
A pipeline, like an assembly line.
Exactly. Imagine 4 distinct stages running at the same time. Stage 1 is specification. Stage 2 is implementation. That's the coding. Stage 3 is software testing. Stage 4 is system integration.
Okay, so these aren't happening sequentially for the whole project. They are happening simultaneously.
Visualize the calendar. In week 2, the developers are coding for Sprint 2. But at the exact same time, the testers are testing the work from Sprint 1, and the PO team is writing the specs for Sprint 3.
So it's a cascade.
Yeah.
You aren't testing what you are writing today. You are testing what you wrote last week.
Correct. It allows the developers to keep moving forward without getting blocked by the testers, but the feedback loop is still very tight, usually just a couple of weeks rather than a couple of years.
That creates a continuous flow. The source calls these certifiable releases.
Yes. Every few weeks, something comes out the other end of the pipeline. And it isn't just working code, it's certified, documented, tested code.
That sounds incredibly efficient on paper. But I want to be the devil's advocate for a second. This sounds like a lot of overhead. You have teams waiting on other teams. You have rigid subtasks. Did it actually work in the real world?
That's the key question. They ran this case study with an aerospace subcontractor working for a major aircraft manufacturer. And they were specifically looking at two things: handling changes and testing efficiency.
Okay, let's look at changes first. In the old waterfall days, if I wanted to change a requirement halfway through the project, what happened?
It was a disaster. A change request in aerospace is a dirty word. You have to go back to the beginning of the documents, update the high-level specs, retrace everything, get 20 signatures. It could delay a project by months.
And with this Scrum method,
They successfully introduced changes on the fly because the documentation and testing are tied to the specific ticket, that specific brick. If a requirement changed, they just put it into the next sprint.
so the blast radius of the change is smaller.
Exactly. You don't have to tear down the whole building. You just swap out one brick.
Yeah.
The study confirmed that they could handle requirement volatility without derailing the certification.
That's a huge win. That's the agility actually delivering on its promise.
Yeah.
What about the testing effort? You mentioned earlier that V&V is usually where the budget explodes because you find all the bugs at the end.
This was research question 2, and the study found that they significantly reduced the V&V effort by catching issues inside the sprint. Because those mandatory subtasks force you to write the test case while you are coding, you catch the logic errors immediately. They weren't finding critical bugs during the final system integration because they had already squashed them 6 weeks prior.
It makes sense. Fixing a bug the day you write it costs $10.
Yeah.
Fixing it a year later costs $10,000.
Exactly. But, and there is a huge but here, the source emphasizes that this whole system collapses without one thing.
Automation. You can't do this by hand.
No way! If you tried to manually write these documents and manually update the traceability matrices every 2 weeks, the team would drown in administration.
So they had robots doing the paperwork.
Essentially, they implemented tools that would scrape the data from the project management system. So when a developer ticks done on review source code, the tool grabs that timestamp, the reviewer's name, the code diff, and automatically formats it into the PDF the FAA expects to see.
That is slick. You're using the workflow tool to generate the legal evidence.
It turns the developer's daily habits into the certification deliverables.
Okay, so the process works, the automation works. But here is the ultimate test. Did the client, the aircraft manufacturer, accept it? Because you can have the coolest process in the world, but if the auditor looks at it and says, this isn't DO178C, you're fired.
The client did accept it, and this is the part I find most validating. The output was indistinguishable from a waterfall project.
Really?
Yeah.
Even though it was built in sprints.
When they handed over the final evidence package for Level A certification, it had all the traceability matrices, all the review logs, all the test results. The client didn't even necessarily need to know it was built using Scrum. The evidence spoke for itself.
It's like stealth Agile. You look like a traditional buttoned-up aerospace firm on the outside, but inside the engine room, you're running sprints.
That's a great way to put it. However, the source does note a challenge here, and it's not technical, it's cultural. The certification bodies, the actual auditors from the agencies, are still catching up. They're used to showing up at the end of a 2-year project and being handed a room full of binders.
Right. They expect the Big Bang audit.
The idea of continuous certification, where an auditor might come in every month to check the latest sprint, is technically possible now. But the bureaucratic machinery isn't quite geared for that rhythm yet.
So the technology is ready, the process is ready, but the regulators are still putting their shoes on.
As is often the case. But the study proves that even if the auditor comes at the very end, Scrum4DO178C produces the goods.
This has been a fascinating look at a very niche industry, but I think the implications are huge. Why should a listener who works in finance or healthcare or even standard tech care about this? I mean, most of us aren't building flight controls.
I think the key takeaway is about the false dichotomy between speed and safety. We tell ourselves stories like, we can't be agile because we're regulated, or we can't have rigorous documentation because it will slow us down.
Right. We treat them as enemies. You pick one.
Yeah.
Speed or quality.
This deep dive proves that is a choice you don't have to make. The secret wasn't removing the rules. They didn't say, let's ignore DO178C. They embedded the rules into the daily habit.
I love that phrasing. Embedding the rules into the habit.
By forcing you to write the test case before you can close the ticket, they made quality the path of least resistance. It shifts the mindset from compliance is something I have to do for the auditor to compliance is just how we build software.
And honestly, the parallel streams concept, that pipeline idea, is brilliant for any complex project. Even if you aren't building safety-critical hardware, the idea of having a specification stream running just ahead of your implementation stream, that just seems like good management.
It creates predictability. And in high-stakes environments, predictability is everything.
It really is. It makes me think about all the other industries that claim they are too complex for Agile. Medical devices, banking backends, automotive.
The principles here absolutely translate. If you can do it for criticality level A, where a failure means a plane falls out of the sky, you can certainly do it for a banking app.
So as we wrap up this deep dive, I want to leave you with a thought. We've seen today that a system designed to prevent catastrophic failures can be agile. It can adapt to change. It can move fast without crashing.
It requires discipline, automation, and a very smart process design, but it is absolutely possible.
So here's the provocative question for you to mull over today. If the people building the autopilot for your next flight have figured out how to be agile and rigid at the same time, what excuse does a typical business have for being slow, bureaucratic, and stuck in the past?
That is a very uncomfortable question for a lot of organizations.
Indeed it is. That's all for today's deep dive into Scrum4DO178C. Thanks for listening and fly safe.